Good morning. This is Saranya, Assistant Professor, Department of Computer Science from Dr. SNS Rajalakshmi College of Arts and Science. Today we are going to see a lecture series on the topic Finite Automata in Theory of Computation. Before enter into the topic, first let us see what is meant by Theory of Computation. Theory of Computation is a branch of computer science. It deals with input as well as set of states in order to solve some technical problems. So the word theory is none other than set of ideas. We are going to give some detailed explanation on some topic. So that's what we used to call as an theory. And computation, the word computation means solving or calculation, set of calculations we are going to perform in order to solve some technical issues. So theory of computation have basically three branches. One is theory of finite automata and theory of complexity and then theory of computability. So these three branches divided in order to solve some problems. According to the problems, we are going to choose over the branch. So in order to solve some complicated problems, we are going to use theory of Turing machine, theory of complexity. In that, normally we have four different machines in order to solve some technical problems. One is finite automata, and another one is linear bounded automata, push down automata, and then Turing machines. So these four machines helpful for solving some technical problems. Among these four, Turing machine is very powerful compared to all other automata. In order to solve some complicated problem, we can focus on Turing machines. So let us see what is meant by theory of finite automata. It's a first branch among the theory of computation. Some small set of problems we can clear with the help of theory of finite automata. It's the least powerful automata under theory of computation. So finite automata is also called as an automata theory. It's also known as theory of computation, is a theoretical branch of computer science and mathematics, which mainly deals with the logic of computation with respect to simple machines, referred to as automata. The word automata comes under the Latin word automaton. Automaton is one of the scientists' name closely related to machine. Next, let us see what is meant by finite automata. What is the purpose of finite automata? Finite automata are used to recognize the patterns. It takes the string of symbols as input and changes its state accordingly. When the desired symbol is found, then the transition occurs. The word transition is none other than moving from one state to another. At the time of transition, the automata can either move to the next state or stay in the same state. Under finite automata, we have two states. One is accept state and another one is reject state. When the input string is processed successfully and the automata reached its finite state, then it will accept. So we can able to develop some applications. The uses of finite automata is in order to implement some stack representation. Finite automata is very much useful, and also in order to develop some artificial intelligence application as well as robotic application, we can choose finite automata concepts in order to develop a relevant application. And then finite automata is a collection of 5 tuples, consist of Q, sigma, delta, Q naught and then F, where Q referred to as finite set of states, sigma referred as finite set of the input symbol, Q naught is an initial state, F is a final state, and delta is a transition function. So transition function means it's a mathematical representation from moving from one state to another. So this is a formal definitions for finite automata. Next, let us see the finite automata model. The first input referred to as I1, I2, IN, and then it's move on to the state of automata. Automata referred as Q1, Q2 till Q1, and then output result as denoted as O1, O2. O referred as output, I referred as input. So input connected with an automata in order to solve and in order to give the model of result, that is none other than out referred as the output. Okay, if you have any queries, please contact me. Thank you for your patient listening.